many years ago, if you looked at our data sheets, you'd find one dielectric constant value on the data sheet. And that was true for decades. And what happened was, just for instance, if you look at one of our materials, it's the RO3010 materials, it's a high dielectric constant material. And for the test method that's mostly used in the industry for test and laminate, it has a dielectric constant of about 10.2. And what happened was, over time, we had customers come to us and say, we're using this material, we designed it, and how the circuit behaves suggests it's not 10.2 dielectric constant. It's actually higher, about 11.2. And we went down the path of investigating that in a lot of different ways. And it turns out the test method that's used to look at the raw material test, as we do, so we test the raw material, we don't test circuits, not for QA anyway.
Right.
But anyway, as we do the raw material test, it's a clamp strip line test. So basically, it's a clamping fixture. You put the materials in, you clamp it together, and then you test it. And just the natural artifact of that test method is you do have some entrapped error, and error is a low dielectric constant. So with that type of setup, you're going to have a lower dielectric constant than a circuit that has no entrapped error.
I see.
And there's other things too. So that test method is a little sensitive to anisotropy as well. But long story made short, we found that what we really need to do is have a test method for us internally that looked at the process control and a good QA type of test of the raw material, which is what we call the process decay. And then we defined another test method that is really looking at how the dielectric constant of the material is perceived in circuit form. So we'll go off and test microstrip transmission line circuits and extract the behavior of the RF performance to get the dielectric constant of the material in circuit form. And that's what we would call design decay. And that value is actually more appropriate for design, simulation, and modeling.